Training is a very running process. In fact, every time you have to put something new to these systems, and your operator should be aware about that. The HAJOP study, all the 6 stages you have to do from 1 to 6. And if there is any changes, it has to be another hazard study is required for that. And accordingly, you have to do the risk assessment and make the mitigation plan for all the risk you involved into the processes. The hazards identification and risk assessment, you have to always identify the hazards by the means of your process audit, safety audits, or the process, there is any changes required, and then you do the risk assessment of this process. These are some comparison between the high explosives like PTN, RDX, HMX, TNT, and NG. You find HMX is much better compound to handle because of the very high melting point. And the others like PTN is very low. That's why the HMX is very suitable compound for making shock tube, multi-layer shock tube, because of the very high melting points. And it is much easier to handle also, and defense is going to use this HMX and more. And that's all. The chapter is not closed here because lots of work to be done in the field of this HMX and their compounds. Systematic study, particularly with the reference to the isolation, identification of intermediates and byproducts, their thermal stability and the variations in the experimental conditions during HMX manufacturing. Thank you very much.
Thank you, Mr. Srivastav. I congratulate you and Solar for making a lead in defense product HMX. And as you know, defense spending is almost 2.5 lakh crore, which is around 2.2% of GDP, out of which the capex is 80,000 crore. And our industry, the commercial explosive industry, the total turnover is around 3,500 to 4,000 crore, a meager. So the only way to survive this industry and keep on flourishing is to have a foray into your defense, where we do have a chance, because we are dealing with PTN, which is much more hazardous, and we have an expertise in dealing with much more hazardous chemicals. So we are confident that this industry will come forward and take a part of the load from your PSUs, government PSUs, and share with the government of India their knowledge, their experience of handling the hazardous substances. I congratulate them, and I look forward to the good future for the explosive industry. Now our next paper is by Mr. Mr. T. Vikram, and his topic is hazards in processing bulk quantities of zirconium and potassium nitrate pyrocharge and safe practices for hazard mitigation. Mr. Vikram is a postgraduate in chemistry from Sri Satya Sai University and MTech in Polymer Science and Technology from IIT Delhi. His field of work is research and development of pyrotechnic charges and pyrotechnic igniters for various solid rocket motors. At present, he is working as scientist in Space Ordnance Group of Vikram Sarabhai Space Center, ISRO, Thiruvananthapuram. I invite, please.
Good afternoon to all the delegates, dignitaries on the dais and off the dais. I am Vikram from Space Ordnance Group from Vikram Sarabhai Space Center. I am presenting, though my topic is specifically telling zirconium potassium nitride pyrocharge, I would like to touch upon in general pyrotechnic charges used in igniter applications in solid rocket motors. Authors are myself and Mr. Uma Shankar is our DGM. Mr. Baby Abraham is the Group Director for Space Ordnance Group. And co-authors are Dr. Srinivasa Rao and Dr. Gupta A.N. from Premier Explosives. They are there right among the audience now. Okay, I come from Vikram Sarabhai Space Center, VSSC, ISRO, Thiruvananthapuram, and probably we are something like 100 to 150 scientists and engineers working in space ordnance. That means we are putting the explosives for use in rocket systems. We basically deal with three broad classifications, that is initiatory systems, high explosive based systems used for destruction, separation, etc., and pyromechanically actuated devices for doing various functions like cutting, valve openings, etc., etc. And I am into initiatory systems. The brief outline is introduction and some hazard evaluation methods for pyrotechnic charges, different pyrotechnic charges that are in use in our center. Some briefly I will touch upon safety management because the speaker before me has dealt it in detail. And zirconium and zirconium potash nitrate, accidents in the field of pyrotechnics, more than me I think audience will be knowing better on that. And some analysis of accidents in firecracker industries. What are the impacts of accidents and some general safety guidelines. Okay. Pyrotechnic charges are basically intimate physical mixtures of fuel and oxidizers. Upon ignition, it undergoes a non-detonative, self-sustaining exothermic reaction. In our use, okay, pyrotechnic charges, though you can add some coloring agent, burn rate regulator, etc. for crackers industries, we basically have very simple three-component system, fuel, oxidizer, and a binder for igniter applications. And pyrotechnic compositions are used for various applications for generating heat, smoke, color, light, sound, motion, etc. And for in igniter application, it is mainly the heat and pressure. Pyrotechnic systems are basically like a baby ready to cry. You just need to pinch it and immediately it will start crying. So they are very sensitive to heat, spark. He has already told FISH, FISH, heat, spark, static electricity, friction, and impact. So all these things we have to avoid in the work area. And how do we find out how sensitive they are? There are various instrumentation methods are there for that. For heat sensitivity, differential thermal analyzers, differential scanning calorimetry, able heat test, etc. Friction sensitivity standard equipment is there, Julius Peters apparatus. For impact sensitivity also, bomb fall hammer method, very standard method. Spark sensitivity by ESD tester we can find out. That's how everybody characterizes these explosives and compare and say that this is better than that, that is better than this, safer than that, etc. Pyrotechnic charge preparation basically contains raw material preparation. Then we blend the fuel and oxidizer, that's where the hazard starts. Then a binder is prepared and added to this powder charge and then made in the form of granules. Granules are further made in the form of tablets and pellets. These are the various equipments used for drying hot air ovens, then for grinding either ball mill or hammer mills, then for sieving some vibratory sieve shakers, and for making tablets, this is a very hazardous operation. So we use this equipment, rotary tableting machine, it's customized for our application. It's basically pharma equipment customized and cleared by our center safety committees. Various pyrotechnic charges, well-established charge used in our applications are zirconium potash nitrate, boron potash nitrate, aluminum potassium perchlorate, aluminum ammonium perchlorate, titanium cupric oxide, titanium potassium perchlorate, magnesium teflon whiten, aluminum iron oxide, thermite, etc. They have been used by us. And we characterize these pyrotechnic charges at three different levels. As a powder, we check the composition, calorific value, that is the heat content, then pressure output by firing it inside a closed volume. Then granules are checked for calorific value and pellets are checked for the pressure output. Each stage, powder, granule, pellet, has various applications. A pellet will have a very predefined burning like a propellant. You can tailor make the pellet to meet your applications. Compared to that, granules will burn faster. Compared to that, powder will be burning much faster. Okay, regarding safety management, so safety starts from the design itself. Then later on, imparting training to the personnel also it plays an equal important role. We have to design the composition, equipment, building, process, storage, transportation, disposal, etc. has to be done, designed safely. Then imparting training is a everyday affair according to me. We have to constantly train the workforce and as well as conduct some awareness classes. I think even this seminar itself is, I can tell, a sort of training. And again, refurbishing, we are just recollecting our experiences, sharing our knowledge, etc. While designing the composition, first we have to understand the chemistry of the ingredients, check for the compatibility, read the material data sheets properly, and composition should be safe to process, stable during storage, transportation, and end use. And when it is required, it should be sufficiently unstable to even release the energy instantaneously. And building design, I don't need to tell more. There are STEC guidelines, explosive rules, etc. We have to take care of quantity, distances, wall thicknesses, flame-proof electrical fittings, static discharging of body electricity, conductive flooring, lightning protection, etc., etc. A lot of rules are there. If you fulfill these rules only, we will get the clearances for using those buildings. And while designing these buildings, we have to take the user into confidence. Equipments also we have to design in such a way that materials of construction should be compatible with the explosives, remote operation wherever required, explosion-proof enclosures, etc., etc. We have to use it. Then coming to, these are all in general for pyrotechnic charges. Zirconium potash nitrate, why I selected zirconium is, among all these things, zirconium is very, very pyrophoric and dangerous to handle among all the pyrotechnic charges. And it is actually a regulated and prescribed material, and we have to get approvals from government even for handling zirconium, etc. It's a group 4 metal in the periodic table, and along with titanium, hafnium, rutherfordium, you can see zirconium also in that table. Hafnium and zirconium, they are all like twins, inseparable twins. In powder form, zirconium is very, very inflammable and pyrophoric in nature. That itself we have to handle extremely safely. It is very sensitive to static discharge. Even body static discharge can make it fire. Upon heating, it has very, very less auto ignition temperature, 150 to 200 degrees. It can easily catch fire. These are certain do's and don'ts with zirconium prescribed by NFC. You have to keep minimum inventory in the process area. Whenever there is a fire with zirconium, don't use water. You have to use some dry chemical powder based extinguishers. Process area should be free from any other combustion materials. And we have to maintain RH of greater than 50%. Provide earthing for the zirconium storage containers. Only trained person should handle zirconium. Fully cotton dress should be worn. Anti-static or conductive shoes, face shield, goggles. It is as good as an explosive. That's what I want to convey. Don'ts are like, okay, they are opposite of do's. Okay, even zirconium scrap has to be very carefully handled. Don't just throw it off as scrap. And never ever store zirconium in plastic drums. And zirconium should never be spilt. If it is becoming fine powder, then while spilling and all, that itself will catch fire. And don't use any metallic tools for handling zirconium. It should be non-sparking, non-metallic tools only. And zirconium is basically, it is stored under argon atmosphere, not even nitrogen. And most important is public transportation of zirconium is not permitted. Okay, ZPN charge, as I told, powder, granules, tablets, etc. Routine procedure is there. And zirconium, this basically hazard is mainly flash fire hazard is the flash fire, mass fire. It comes under UN 1.3G category. You can use V blenders for larger scale, but large scale means more hazard, so we have to use remote operations, etc. And as far as possible, whenever handling pyrotechnic charges, especially ZPN charges, we have to use personal protective equipments, but this is the last resort. Don't think that PPE is the first defense. This is the last defense. And the sieves we have to earth the sieves necessarily while processing the zirconium potash nitrate charge. Manual processing involves, granulation involves making a dough, then corning, that is passing it through some sieve and then dry it at room temperature, not at high elevated temperatures. We can even make the dough using sigma mixer. And afterwards, it is made in the form of tablets using a tableting machine. Here, minimum processable charge quantity only we have to maintain, something like at a time 150 to 200 grams. That is to minimize the hazard. We can keep on replenishing that. The various accidents I have listed. Okay, some of the this literature is taken from a literature. Some over a decade, some study is done on accidents in fireworks industries. It is salient point is accidents mainly take place during tea break, lunch break, evening, etc. So those times one has to be careful while working in explosive industries. And mainly number of accidents are mainly explosions or more than other fire, etc. And unsafe acts are mainly responsible for many of the accidents. And most probable reasons for accident in general is non-compliance with standard operating procedures, instructions, safety instructions, standing instruction, etc. Non-adherence to maintenance of the equipments, and most important is low priority to safety due to production and schedule constraints, etc. Human error due to complacency arising from the familiarity with the process or the equipment or procedure. You can broadly classify many of the accidents under this category. What are the impacts of accidents? I think all of us must be knowing it well. First, it will lead to injury or death of the personnel and related complications. Loss of property. It involves some downtime. Some months of production may get stopped and our business may get hampered. Reputation of the establishment also takes a hit. It will come everywhere in news, etc. Then, and above all, the loss of confidence to the persons working in that area and the colleagues. That is again, we have to bring back the confidence and restart the process. Some of the general safety directives are like this. You should always expect the unexpected thing, though it is negative statement. Never work alone in the field of explosives. Start with the smallest possible quantity. Use safety shields wherever applicable. Earth the facilities. Wear all the prescribed personal protective equipments. Maintain a RH of around 50 to 60%. Good housekeeping is very, very important. And know the material hazard and tell the material hazard also to the people who are working. And follow the standard operating procedures. To conclude, processing of pyrotechnic charges, it's anyway hazardous. You cannot totally eliminate the hazard. You can only reduce the hazard. We will have to try for zero accident. Automation is key for reducing the risk to the personnels. And many safety checks, standard operating procedures, etc. for mitigating the hazard has to be followed. Golden rule in the field of pyrotechnics or explosives is give respect and take respect. If you respect the explosives, it will respect you. And we have to always remember these three sentences. Ignorance is not an excuse in this field. Negligence is never tolerable. Overconfidence is never pardonable. Yeah, I thank the organizers, the participants, co-authors, and the peer reviewer, Mr. Dr. Nalla Perumal, our VSSC editorial board and director VSSC for giving this opportunity. And in fact, this zirconium potash nitrate charge and igniter for ballistic evaluation motor for our ISRO application is currently being made by Premier Explosives. They have successfully, we have transferred the technology to them, and they have given more than 3,000 igniters, and its performance is very good. I would like to mention that point also at in this conference. Thank you very much.
Thank you, Mr. Vikram, for maintaining the time, and a very useful paper, which is useful for entire explosive industry, more so for the accessories and the initiative system. Many of the points can be taken a leaf out of and used in our detonator making. So I congratulate you, and now our next paper is presented by Mr. Shiva Prasad, GN Shiva Prasad, on process safety management in initiating system. I'll introduce Mr. Siva Prasad. He is a 1981 batch postgraduate in organic chemistry, also an MBA in finance, postgraduate diploma in personal management, and diploma in instrumentation and chemical technology. He has more than 35 years of experience in explosive industry. He has worked with Orica, Tamil Nadu Explosive, Premier Explosives, and pharmaceutical industry. Currently, he is working as General Manager Operations with Ideal Detonators Private Limited.
Good evening, everybody. Respected chairman of this session, and we have a galaxy of intellectuals before me, and lot of subject experts, and also many manufacturers here. This process safety management is applicable to every manufacturer of explosives, whether it is a emulsion plant or slurry plant or a detonator manufacturing plant or a detonating cord manufacturing plant, any plant related to explosives. This process safety management is applicable to all the manufacturing activities. Why process safety management? Because every company has limited resources, and with these limited resources, we have to achieve our business and objectives. That is ultimately profits, maybe business expansions, etc. So for this industry, our explosive industry, a structured risk-based approach will give us a better working method. That is, we can work without any accidents or without any hassles and confusions. So the structure, actually, that is, we have to anticipate all the risks which are involved in the manufacturing activities, that we have to foresee and make a structured risk-based approach. And this can be achieved by institutionalizing a risk-based culture. Risk-based culture means, again, informing and imparting the knowledge about the risk to all concerned stakeholders in the manufacturing activity. So this is briefly why process safety management and why process safety management is needed. See, even when we design a manufacturing activity or well planned and constructed and operated unit also will have operations which can become hazardous. So to mitigate from these hazards, the process management, safety management helps us. So incidents can happen even when safety requirements are not identified, assessed, or risk analyzed. So process management dealt with these issues and clearly indicates how to go ahead. And third, appointment from employees of workplace, contractors, and their workmen and visitors can be at the workplaces. So process safety management addresses all these safety issues. Definition of process safety management. Process safety management may be defined as a tool to design an industry to operate without endangerment of environment, engaged manpower, and equipment, and in large community. This is what our safety distance of different process buildings, and there, in case of an accident, what is the effect on the offsite. All these things will be part of the process safety management. So this will give without endangerment of environment, so non-pollution of the environment, and manpower safety, and equipment and community safety. And here, objective is to evaluate hazards and risks involved in the initiating systems manufacturing and general mitigation measures to run all operations without any hurdles and confusion. And every stage of operation should have a clarity of thinking while performing, and the process safety management gives as a part of it. And process safety management, actually it should come from the top level of the company management, because at the shop floor levels or factory level, even if we plan, unless there is a drive from the top, it cannot be implemented. That is the most requirement for many of the manufacturers, which we are in small scale, manufacturers particularly. So process safety management, it is a strategic plan to be designed in principle at top management level to percolate down the line of organization, concept and philosophy of the PSM to have no injury to anybody and no loss to equipment and environment. So any safety system should come from the top level to implement at the shop floor levels and factory level. And benefits of process safety management. Process safety management assures occupational safety, protecting against all the personal injuries. I have given a list of activities: slips, trips, falls, falling from height, and loss of contamination, release of materials, losing of the materials while transporting, all these things, loss of contamination, pollution of the environment, all these things can be avoided with a proper safety management plan. And PSM should become a formal platform to assist for improvement of operational effectiveness. That means proper safety system should be designed to convey this. PSM becomes a platform for that. And PSM is a mechanism to engage and solicit input from various stakeholders. The management systems, safety management system is to be designed involving every stakeholder, that is at the factory level, operators, the managers, officers, shop floor supervisors, etc. So this stakeholders' involvement is the most important to evolve a proper safety system, because it should be understood by the working level people. And PSM empowers employees to be an active program participants with the development and ongoing sustainability of safe working environment. So this is, again, involves the employees, stakeholders here, protects the workforce from any unforeseen events. So initiating explosive chemicals, as already many of my colleagues have described, that leadazide, lead stiffenate, PET and TNT, stiffenic acid, etc. These are very sensitive chemicals that I need not repeat again. To prevent any unusual occurrence from these chemicals, that the process safety management is to be evolved in initiating systems, because particularly all chemicals are sensitive to heat, fish, somebody has told, friction, impact sensitivity, and heat, static current. These are the major enemies to our manufacturing operations, that we have to put all these things under control. Then managing systems, during management system, standards serve as an excellent vehicle for codifying technology, best practices, and experience. The bigger challenge is to ensure that all levels of the company apply these standards in their day-to-day operations. That is, first step is to establish the standards to suit your plant requirements. What I apply in my company may not be suitable in the other company, because the copy and paste method may not be suitable always. That is the most significant part. And all components and tools of process safety management are to be recognized. What are the requirements of safety equipment, personal protective equipment, or other equipments like humidity maintenance equipment, or etc., to be recognized, and they should be installed properly. And management system. Management at top level should focus on senior leadership commitment with written programs with responsibilities and defined matrices and continuous improvement. This is already I emphasized this in starting itself. And commitment to carry out with compliance all statutory mandates and obligations also become part of PSM. Hence, process safety management implementation significantly links to top management policy, and proactive action from the management only can make an organization to operate in safe work environment, and in turn it can result more ROI. ROI means return on investment, I said, because when there is no accident, there is no loss of work days or anything. So there will be more ROI. And sharing of process safety information is the most significant thing. That is, everybody has to understand about the chemicals they are using in that. So this is a important process, sharing of the process safety information. And chemical data of all chemicals need to be understood. And equipment data availability is an important aspect to ensure the right way of handling of equipment and mechanical integrity of functional aspects. This is the most important mechanical integrity of functional aspects. This often failure of mechanical integrity will lead to some major events or maybe smaller events, but the mechanical integrity of the equipment is the most significant factor that proper preventive maintenance, running breakdown, maintenance, all these things should be considered. So, and process deviations. This is often a normal issue in every plant. So we make operation instruction something, and in the building it goes something different. And so when there is a problem, then we run for that and see what happened. So there is a deviation from this. So if we know the deviation consequence, we can determine the level of risk also. So there should be minimum deviations or no deviations. And a deviation can become a regular practice after. If it doesn't have any negative effect, that we continue to implement that deviation. Actually, any deviation should be properly authorized by the management. Then only it can be a right way of working. And risk assessment can be assessed by different techniques. Here I have given 2-3 names of the techniques. And this is training and assessment. This is a significant factor. Actually, here the depleting skilled workforces within the process and increasing demand for local employment and an increased dependency on outsourcing of contractors to perform specialized tasks are contributing factors to the declining explosive industry process knowledge and increased operational risks. This is one of the important areas I feel that people can look at this issue, because they're depending on the training is most significant. Whether whomever we take, there should be a proper training and induction. Then there can be, I think, no incidents. This is, I have written next. While most companies understand this challenge, some amount of money has been spent on training without following up to build the required skills. It may be more effective to spend more time on coaching and skill building through on-the-job application to achieve better results. The skill development is another important area where many organizations are missing this opportunity, I think. So program outlining requirements, etc., these are normal things. Training should be made a mandatory thing, and there should be a proper training calendar to carry out the activities. The management of change. This change management program, this is if we make any change in the operation, it should be properly authorized, because I cannot make a change in my shop floor without knowledge of my superiors or other concerned people. Because if I make change, it may result maybe good, as long as it goes well, no problem. But if it results in a negative aspect, then the questions will come. So that's why the whatever change we are making at shop floor level, take it to at all stakeholders and make it a authorized operation change and get it to implementation. So then there will be no risk of having any dangers, because it goes through the cycle of all experts of concern in the factory. And incident investigation, many people have discussed about any incident investigation. This is the most significant thing. If we have a credible team which can investigate into incident impartially, then there will be more better opportunities to correct that mistake and see that no injury or no incident happens again. Emergency preparedness, this is, everybody knows this is a statutory requirement, but many of the supervisors, shop floor level supervisors, should be well acquainted with these concepts, what is site emergency, what is off-site emergency, how to deal with these things. There should be a proper training in this area also, emergency preparedness. And to know our state of safety, process safety, there should be a periodical audits. There are many kinds of audits. So we can do any type of audit, a full length audit or a walking audit, any type of audit. So you know the status of the safety. And similarly, if we do it by third party, we can know what is our audit's worthiness. That is another important. So employee participation in all the
Mr. Shiva Prasad, you have got 1 minute to go.
yeah, okay.
Kindly close up.
Yeah, right. Just I will take one more minute, that's all. Say an organization functions with individuals as employees with different hierarchical levels with coordination. This says that there is a teamwork, and teamwork demands a team spirit. That is, working together with all our tools will give a better result than what I work as an individual. So the team spirit has to be built up. And managements also should, apart from statutory committees, there should be like these things to be carried out with some other platform, and then these things will be improving. And process hazard analysis review. Hazard analysis should be reviewed once in a year, once in 3 months or once in 6 months or once in a year, depending on your requirement. We have to review our process and then assess whether our process is sustainably is safe or not. Reviews will help us to know the status of our process and its loopholes coming. Good manufacturing practice will always bring out the loopholes. If there is a good manufacturing practice, it will come automatically. And management system to address action. So after all these things, ultimately I have to go to my management, say, yes, I want these things, please provide me. So that I can run my plant without any accident. The concept is zero accident. Nobody should injure in any operation. These components are not my own. I have read from OSHA's. This is all OSHA's deliberations. They have done after so many accidents. They have studied all these aspects, and they have tabulated these aspects. Still some more aspects are there that I could not incorporate here. So ultimately, process safety management, operational spirit in implementation leads to improved results. That is the most important. The management operational spirit, safety management operational spirit is required. Its implementation will definitely give no accident days. So then we'll have no loss of working days. So no breakdowns, no losses, and everybody is happy. How I goes to factory daily and I will be back to my home within same way. So that everybody wants that. How I go to factory, I have to come like that only. This is what my is interest, process safety management. This applies to all manufacturing activities, irrespective of that. Okay, thank you for it.
Thank you, Mr. Shiva Prasad. Now, before I invite question answer, I would like to make a few observations. As a chairperson, it's my prerogative, and I would like to make them. First of all, the papers were very good, very comprehensive, and but I would have loved if those papers had some case studies. Need of the hour is to have some case studies. And I would like to congratulate Mr. Kamal Peso and the MWA for making us open up. The second session which has taken place, first was in 2013. Prior to this, we were all hiding the information amongst ourselves. If an accident used to take place in the industry, all industry used to know, but we will never share with them. Now a change is taking place with this Explosafe coming. People are sharing information. And this is a very encouraging thing which is happening. People are sharing their accidents. They are all act of omissions they are sharing. And it is very, very necessary because, accidents you cannot avoid, come whatever you may try. What has happened? This dynamite has come out of an accident. And think of the days if he was prosecuted under penal code, what would have happened? Where would have science gone? So my request is, the fear of reprisals suppress the information, and the people suffer forever because you tend to suppress the information of actual causes of accident. My request to the authorities is, let us give a clean cheat, a blanket pardon to the persons who come make a clean breast of the what has happened. Same thing happened with the workman when the management, they have a fear from the management. They suppress the information, what led to the accident. The management is not very welcoming to get the information, so the truth doesn't come out. And worst of all, in the industrial disasters, where is the role of police? I fail to understand. Is the role of the industrial statutory bodies who are supposed to do it, the Department of Factory, it is the Department of PESO. They should come into the picture. And they come, but there is another fear coming. The coming is the fear from the statutory, district authorities, the police authorities, and as you have already seen, 2 or 3 accidents, but the industry is totally in bad name. वो हिंदी उर्दू में एक कहावत है कि वो कत्ल भी करते हैं चर्चा नहीं होती, हम आह भी भरते हैं हो जाते हैं बदनाम. So this is what is happening with the explosive industry. The accidents are not so severe and not so much as it is being projected out of. Thanks to the media, thanks to the your authorities, police authorities, I have found PESO taking a very lenient view. They try to go into the details, they try to discover the things, and it is required because you know if you see all the accidents, all the explosive characteristics which has come, which have been discovered, it has come out of the accident. Ammonium nitrate, who knew about the explosive characteristics of ammonium nitrate until that accident which took place? TNT, people were using it as a coloring agent. They did not even know that this is an explosive. So the discoveries are taking place despite of our best intention, accidents take place, human error take place. This forum is a right place to discuss, educate other people about what has happened, why not to repeat it, more frequent meeting and exchange of views is required, and to that extent, the industry is opening up. I congratulate and I thank PESO for taking a lead on that, and they are really doing their job as a safety organization or regulator. I congratulate them. Now, as I have already pointed out, about defense is opening up, and we are expert. We are dealing with much hazardous substance, and there is a time for us to accept this challenge. Let country gain, because whatever others produce at say 1,000 rupees, we will produce at 100 rupees. Who had ever thought that still in these days 25 rupees we are selling the explosives, when back in 78 we used to import explosives at 50 rupees a kg. 50 rupees a kg of 78, and today 25 rupees. So our people believe in frugal engineering without compromising on the safety, and if defense comes to the private sector, it's the country which gains because the efficiency will improve. So I congratulate all. I congratulate PESO for taking the lead, and I request that this should be done more frequently, maybe once in 2 years, so that we share views, we share our case studies, and we share our failings as much as our glory. Now I invite question answer from all. There is one question which has come. This is for you only. You please read it out.
Mr. Ninad Gawade, Deputy C, has asked about the ventilation wall. Normally in the nitration area, people use diaphragm valve and other type of valve to reduce the hazards. You can use ball valve, is having a ventilation into that. If there is any pressure involved there during the runway reaction, it should release. It's a very special design ball. Say half of the circle is there. They can release the pressures once there is a pressure increased because of any runway reactions. So that is type of valve we call ventilated ball valves.
Any more question?
It is a batch process.
HMX we are using as a batch process. Alpha isomers is formed. We have added gamma. Alpha is formed during the nitration, but it is isolated during the simmer process. The melting point is 275 to 277. Is changed, it can be changed on the basis of the methods you are using. If you are using DSC and different scales, that can be different. But with a normal melting point, it should be within 273 to 277 degree. The yield is, with this batch process, is coming around 70%. And the effluent treatment, what are the process we are using? What TBRL Chandigarh is using, they are making 1 kg of HMX and generating 100 kg of effluent. But the solar is making 1 kg of HMX is generating only 15 kg of effluent. And that is also distilled, having a vacuum distillation system, where all the water is distilled out and can be used anywhere. And the substract is the ammonium acetate or sodium acetate, is a very good descaling agent, which we are using as a descaling for any condenser and certain things.
Any more questions? Okay, thank you very much. So we'll wind up our session. Now I hand over the.
Thank you, Mr. A.D. Sao, Ideal Explosives, for chairing this session. Also thanking all the speakers from the second technical session for today. I would like to request our chairperson, Shri A.D. Sao, to present mementos to all the speakers for this session. May I please request our chairperson to present the memento to Shri Rakesh Kumar, Indian Explosives Limited, Gomia. Shri A.K. Srivastava, Solar Industries India Limited. Shri T. Vikram, Vikram Sarabhai Space Center, ISRO. And Shri G. N. Sivaprasad, Ideal Detonators. Thank you, Shri A.D. Sao. Now, I would request Mr. N.V.R.A. Raja from Shri Vishnu Explosives to present the memento to our chairperson, Shri A.D. Sao. Can we have a round of applause for Shri A.D. Sao for chairing this session? Thank you. After these two technical sessions, ladies and gentlemen, we will take a tea break here. It will be a 15 minutes tea break, and I would request everybody to adhere to the time so we can begin our third technical session. Also, to remind all of you that around 7:30 p.m., we have a dinner and entertainment program for all of you present here today. So please be back at 7:30 to enjoy dinner and entertainment with us after our technical sessions are over today. Thank you very much and enjoy your cup of tea. Bouquet of flowers. I would request Mr. Kundan to do the honors and welcome Shri A. N. Gupta with a bouquet of flowers. Dr. A. N. Gupta is a 1968 batch postgraduate in mining engineering from Indian School of Mines, Dhanbad. He is recipient of ISM medals and gold medal from Mining, Geological and Metallurgical Institute of India. Dr. A.N. Gupta has worked in the Department of Technical Services and Marketing of Indian Explosives Limited from 1969 to 1979. At present, he is the Chairman and Managing Director of MS Premier Explosives Limited. May I now call upon the speakers for this third technical session. I would request Sri Rahul Guha, Solar Industries India Limited, Nagpur, to come and join us at the dais. To welcome him, I would request Mr. A. Maulik from Special Blast Limited to present him with a bouquet of flowers. I would now request Shri N.T. Shahu from PISO, Nagpur, to come and join us as a speaker today. I would request Mr. T. Lakshmanan from Tamil Nadu Industrial Explosives Limited to welcome Shri N.T. Shahu with a floral bouquet, please. And our next speaker is Dr. Sanjay Kumar Roy, CSIR CIMFR, Dhanbad. I would request Mr. Venkateshwar Reddy from AP Explosives to welcome Dr. Sanjay Kumar Roy with a bouquet of flowers, please. Let's give them all a round of applause. Thank you. I welcome our chairperson and all the speakers. And now I would request our chairperson to chair this particular session. Thank you.
Dr. Kamal and all the dignitaries of the dais and speakers on the dais. You're all welcome to this session. This is a third session technical. My job has been made a little easier because the earlier session chaired by Mr. A.D. Sao also had a similar sort of a subject, and he spoke whatever I wanted to speak. But I want to add a few things. I always tell my people in the factory that my priorities are, first priority safety, second priority quality, and I know that productivity will certainly follow. I think it is it's a very appropriate message to your employees, and I hope all the senior people follow the same. Accidents are very unfortunate incidents because it results in loss of life, loss of property, loss of machinery, loss of productivity, time, and so on. But when happened, we must not lose that opportunity because it's a very excellent opportunity to learn. Whenever it happens, yes, we have to take care of all the statutory things and all that, but ultimately we have to use it as a learning experience. And normally in Premier Explosive we do the same thing, that we use it as a learning experience. We have a unbiased sort of a investigation into that, involving the operators at the site, the supervisors, the officers, and anybody who can contribute on this, including outside experts. that learning from this is only for our own people. I would really be very, very happy if this experience of learning we can share with everyone, all the colleagues in the industry, so that we not only learn from our own faults or any problems which has taken place either voluntarily or some caused by somebody by a mistake, so that the other people can learn from that and we can avoid and make explosive industry a zero accident. I think it will please everybody. Here, there is one factor which comes in. People don't come out with the actual things is because they feel that they may be prosecuted. So this, I think, fear has to be sort of reduced by our Chief Controller Explosives and all officers of PESO, who should encourage this sort of investigation. I think A.D. Sau also said the same thing, not in so many words probably. I will request that, and many a times we have seen in the past when we had shared accident histories like what happened in Tamil Nadu Explosives at one time and other places, that we had a meeting of all the manufacturers and we all sort of expressed what we are doing, and then we could come to a conclusion that what has caused the accident, and it became a learning experience for everyone. I would request that anytime any accident, small or big, happens, if we can do this, we'll all learn from each other's experiences. With that, I think I will start the session because we are a little behind schedule. Our topic is our first speaker is Mr. Rahul Guha, and his topic is explosions in detonator assembly building. Mr. Rahul Guha did his BSc and BTech chemical engineering from Nagpur University before joining ICI Explosive Division at their factory in Gomia in 1967. He has worked as business manager for safety, health, and environment with ICI. He is also one of the 12 governors on the governing body of the SafeX. And here again, sir, in SafeX we go and share our accidents without any inhibition. Members of SafeX, we are going there and sharing our accidents and their experience there. But in India, we don't do it. So I think you will have to, sir, kindly take a lead to encourage this so that we can share it in India too. Only one from India representing Asia Pacific region. Currently, he is working as Senior General Manager Technical with Solar Industries. Over to Mr. Guha. Please remember 15 minutes your time, and your time starts now.
Thank you, Dr. Gupta. Dr. Kamal, the speakers on the dais, and members of the audience. I think throughout the day we have been deliberating, hearing about the technicalities of how to make explosives, how to safely make explosives. But this session is something where it's a very costly way of learning from experience. What I'll be talking about is an incident, an accident which had happened in our subsidiary company in that is Economic Explosives Limited. Before going into much, what I would like to just first summarize, on the 24th of March 2013, around 15:30 hours, in the fill shell room of detonator house number D11, an explosion took place where the number of persons who were fatally injured were 2, number of persons injured were 2. There was extensive damage to the buildings, but no effect to the surrounding buildings. Now, just to fill you into the background, what is the process outline of the operations that was being carried out in that field shell where that incident took place? The operator brings a case of field shell containing about 4,000 detonator shells from the magazine to the field shell room. He takes out a carton with 100 shells and places it on the table. The carton with the field shells is it is tied with a gum tape so that the top cover and the bottom, they are actually attached to each other. So what the operator does, he takes out the gum tape, opens up the cover. He just visually inspects whether there are any foreign materials or not, and he notes down the batch numbers over there, and then he puts back the cover, and with that he puts that 100 shells in a tray, wooden tray, which is placed next to him on the table. When 4 such cartons have been placed in that carrying box, this person has to carry the same carrying box and takes it to the crimping cubicles where he distributes these shells for the crimping operators to carry out the crimping operation. On the 24th of March 2013, a number of senior managers were at a meeting in a conference room. Around 10 hours, the managers heard the sound of an explosion of low intensity, followed by another one of high intensity. Managers rushed out and saw intense smoke coming out from that particular building. One operator was seen to have been thrown out of the building for about 20 meters from the building with serious injuries. 2 other operators had burn injuries. All the 3 operators were immediately shifted with the company ambulance to the hospital. But the person who was thrown out about 20 meters from the building and who had very serious injuries, he passed away on the way to the hospital. Later, when we went into the building, we found the operator who was actually carrying out that operation of removing the carton, inspection, etc. His body was found inside that room with his feet pointing towards the entrance to the room. Now, what we did is, the first thing is naturally you examine the site of the incident. What we found is the concrete roof of that shell was completely blown off. There were wooden racks all around inside the building on which we used to keep these field shells. There was severe structural damage. A number of exploded and unexploded detonators were found. 2 craters of about 2 feet by 1 feet were seen on the floor of the field shell room. No detonators in the crimping hall were affected. The charred but intact body of the operator was seen lying on the floor with his legs facing the door of the room. Then we started gathering information. The field shell room had a licensed capacity of 30,000 detonators. At the time of the incident, there were about nearly 27,000 detonators in the room, comprising of different types of delays. On the fateful day, in the second shift, operations had started as usual at 2:30 p.m. One packed case containing 1,500 numbers and another with 600 numbers of detonators were kept on the floor where the craters were found. Another partially filled case from which the operator was removing the cartons was placed near the base of the table on the left side of the operator, who was sitting on a stool. The rest of the detonators were placed on trays and kept on racks provided along the walls. Then we went into the various possible causes. Sabotage was ruled out due to lack of evidence. Heat and fire. There was no jungle fire or any sort of fire or any fire inside the building due to short circuit, that was not there. No, there was no evidence to support that. Lightning strike, it was a clear sunny day, so there was no question of any lightning striking and setting off the detonators. Spark from electrical short circuit, only flame-proof fittings were provided inside the building. Static discharge, the operator was wearing cotton clothing, working with bare feet, tabletop and flooring had conductive rubber, hence ignition due to static discharge was ruled out. Friction was the other thing we looked at. Since there was no handling of loose detonators by the operator, a frictional event also we ruled out. Then we narrowed down to impact. Now, ignition due to impact was debated in detail, and 3 scenarios really emerged. Impact due to falling of any object from a height on the detonators kept on the table in which the operator was sitting. This was ruled out as there was no heavy object or light fitting placed above the table. Second was the impact of the detonators falling on a hard surface. Since the flooring had a soft conductive rubber sheet, ignition due to falling of detonators by itself was ruled out. The third possibility was debated in detail. In this case, while lifting the carton of this long delay filled shells, the carton weighed about a kg. What we suspect is he had taken out the tape and he was trying to put it into that carrying box. So when he was holding it, the top cover came out and the detonators in the bottom, they start falling down. So as a normal reaction, what happens is I would try to just bend and try to arrest the fall of the carton. While doing so, what we imagined was that he disturbed the carrying box which was on the table sitting next to it. The table did not have any beading to prevent the box from really tipping down. So what we suspect that when he reacted and tried to hold the carton, he disturbed the carrying box, and the carrying box weighed about 2.5 kgs as such, along with some detonators inside. And the falling carrying box, it impacted on the detonators which had already fallen on the floor. The fall height from the top of the table to the carrying box was about 1 meter. We did simulation trials were carried out using dummy detonators, and it did confirm that this could be a most probable cause of the explosion. That the explosion initiated at the ground level was gauged from the fact that the bones of the legs of the operator were severely crushed. The body of the operator was observed on the floor with his legs pointing towards the entrance of the room, which indicated that the blast had taken place at a low level and it had hit him on the legs, because of which his legs bones of his legs got severely crushed and he was thrown out that way. The presence of some cartons of delay-filled shells in a box near the base of the table from which the operator was taking out the cartons for inspection. The initial explosion transmitted to the other shells stored on the racks. So what people heard was the initial little small explosion followed by a big blast. So this is really what had the incident that had happened. So in order to avoid, as I said, it's a very sad way of trying to, it's a very expensive way of trying to, sorry. Yeah. So as I said, that it was a really expensive way of really learning from an incident. So but what we did is, what we decided was that no operation should be carried out in a filled shell room. it should only be used as an issue room. Removal of gum tape from cartons and recording of batch details would be done in an adjacent room. Fill shells store and distribution room should have weak walls to act as a blow-off panel. Inspection and counting of crimp detonators to be shifted from the main crimping hall to the packing hall. So this is the thing which had happened, and the take-home message from this sad incident was that, really speaking, every hazardous operation should be assessed for the risks. Inventory of explosives in any operation should be kept at the bare minimum. Design of the buildings have an important bearing on reducing the effect in the event of an explosion. This is what the layout of the building was before. This was where the incident happened. This is the table where the operator was sitting, and these were the racks on which these detonators were kept. This explosion took place, and the whole explosion wave traveled this way. And this operator who was thrown away about 20 meters, he was actually entering the building by switching off some light. And as he was entering, the explosion took place, and he was thrown off about 20 meters.